Another way of monitoring your isolated protein is through electrophoresis. In electrophoresis, we take advantage of the charge of your amino acids. But in this type of electrophoresis that I will discuss, okay, we actually introduce a constant charge on all of your protein molecules. Okay, in essence, we just allow the proteins to move along the gel via their size. Okay, so what is electrophoresis? So this is a specific type of electrophoresis. It's called SDS PAGE, short for sodium dodecyl sulfate polyacrylamide gel electrophoresis. So originally, electrophoresis was used to separate protein. So it's also a purification technique. But if you are, for example, employing chromatographic techniques, you can use SDS page to monitor each step of your purification protocol. However, unlike getting the absorbance of your protein at 280 nanometers, you perform electrophoresis after finishing all the steps of your protein purification. Okay? So, what is PAGE or polyacrylamide gel electrophoresis? So, you have a gel which is made of polyacrylamide. In this gel, you have spaces through which your protein molecules can pass. Now, if you just have PAGE, so you have polyacrylamide gel electrophoresis, you um, separate your proteins depending on their size and charge. So, you apply an electric current through the gel, and this will allow your proteins to move inside the gel. Positively charged proteins will move towards your negative electrode. Negatively charged proteins will move towards your positive electrode. At the same time, the size of the protein also dictates its rate of movement through the gel. Bigger proteins will find it harder to move inside the gel, while smaller proteins will find it easier to move inside the gel. Now, if we employ SDS or sodium dodecyl sulfate plus denaturation of your proteins, so your proteins, when they are denatured, they are just these polypeptide chains, right? And your SDS or sodium dodecyl sulfate can attach to this polypeptide chain. Now, your SDS is negatively charged, and they attach to your polypeptide chain in a specific ratio. So in essence, if we do this SDS page, we are canceling out the effect of the protein's charge, and they only move according to their size or molecular weight. So all of them will move toward the anode side or the positive electrode because all of your polypeptide chains are negatively charged due to the SDS. Now, we will not dive deeper into SDS page um, into electrophoresis in general because we have another module for that. So this is just to show you that SDS page is a method used to visualize your isolated protein. So this is an example. This is a scan of a gel. Okay. Um, each lane, we call these lanes, each lane corresponds to a specific step in your purification procedure or protocol. So we can see that in the initial steps of our purification, we still see a lot of proteins. But in the latter steps, we now see one single band, which means that we are confident that we have successfully isolated the protein from the rest of the proteins. So this is the output of your SDS page. You will see bands in the gel because your proteins will stop at a specific point according to their molecular weight. Okay? So these are visualized by staining the proteins inside the gel. So after running the gel, initially you don't see bands on it, but you will stain these proteins. The most famous stain used is called CBB or Kumasi Brilliant Blue. So this dye has a high affinity with your protein molecules, regardless if they are in the native state or in the denatured state. So these dye will bind to the molecules inside the gel and it's color blue so you can see the bands of proteins in your gel. Now, if you have very small concentration, very small amount of your proteins, you can also use a different staining method to visualize the protein in your gel. You can use silver staining, which is more sensitive. The process is actually similar to how you develop photos. So you use silver to know where the proteins are in your gel.